Hello grade 11 students. In this lecture I'm going to revise the last thing we have explained in class, which is the sign of quadratic equations. So we have already learned about the quadratic equations and how do we find the root. Now we're going to discuss the sign of the quadratic equation. So let us remember together. So if the delta of the quadratic equation is negative, then there is no real roots. And in this case, f of x means the quadratic equation cannot be factorized. So what's the sign will be? The sign will be the same as a. What's a? It's the coefficient of the second degree. Okay, so if the delta is negative, what's the sign of the f of x? It takes the sign of a. So if a is positive, then f of x is positive. If a is negative, then f of x is negative. Later on, I will give a lot of examples, but now we are going to discuss together the sign, okay? Now, you know that when delta is equal to 0, we have two double roots. What's the meaning of two double roots? Means they are the same. So x1 it's the same as x2. It's equal to minus b over 2a. In this case, f of x could be factorized. We take a as a coefficient. And now, for the sign, you still remember we have one root. We put it on the table. The table is from minus infinity to plus infinity. This is the root. And the sign of f of x is the same as sign of a. So if a is positive, then we have plus, plus. If a is negative, we have minus, minus. So till now we have learned, if the delta is negative, it will take the sign of a. If it's delta 0, then we have one root, and also it takes the sign of a before the root and after the root. Now what if we have delta positive? You know that when we have delta positive, we have two roots. x1 equals minus b minus radical delta over 2a, and x2 equals minus b plus radical delta over 2a. And now we put the two roots on the table, x1 and x2, and you still remember inside the root, opposite sign of a. So we have same, opposite, same. Okay, you still remember this. We have learned it in class. So we said when we discuss the sign, we say inside the root, opposite sign of a, and outside the roots, same sign as a. So if a is positive, what do we have? Plus, minus, plus. If a is negative, we have negative, positive, negative. So let us take some examples. The first example, we have 3x squared minus 4x minus 7. Without doing delta, you know that a minus b plus c equals to 0 because a is 3, b equals minus 4, and c equals minus 7. So a minus b plus c equals 0. In this case, we have the first root x1 equals minus 1, and x2 equals minus c over a, which is 7 over 3. So in this case, we have two roots, okay? We put the roots on the table, so we have minus 1 and 7 over 3. A is positive, so same, opposite, same. So we have plus, minus, plus. So we say that this trinomial is positive between minus infinity minus 1 union 7 over 3 plus infinity, and it's negative between minus 1 and 7 over 3, and equals to 0 at minus 1 and 7 over 3. So this is the discussion of the sign of the trinomial. The second example, f of x equals 4x squared minus x plus 6. In this case, delta is negative. So always remember, if delta is negative, the sign of the polynomial will take the sign of a. What's a? A is 4. It's positive. So f of x is positive for any real x. That's the sign of f of x. So f of x cannot be negative for any root, for any solution, for any value of x. Here we have minus 5x squared plus 20x minus 20. In this case here we have delta equals to 0. After solving delta, you will get delta equals to 0. So we have double root x1 and x2 equals to 2. So we look at a is negative, so f of x is strictly negative for every x. Okay, so again we have three cases. If delta is positive and we have two roots, same, opposite, same. If delta is negative, it takes the sign of a. If delta equals to 0, it also takes the sign of a. Another example, here we have minus 3x plus 2 over 2x minus 11. We always take a condition. Do you still remember that when we have fraction, we need to take condition. 2x minus 11 does not equal to 0. That means x does not equal to 11 over 2. And we have, if you put them together, it will be minus 6, so it's negative. So pay attention, okay? So we put them as if they are multiplied to each other. So we get that a equals to minus 6. Which is negative. So in this case, it's gonna be negative outside the roots and strictly positive inside the roots. So if you put them on the table, okay, if you put 2 over 3 and 11 over 2, okay, always remember that inside the roots, opposite sign of a. A is negative, means inside is positive, and outside the root is gonna be negative. Okay? So this is the table. Now, why 11 over 2 it's shaded? You already know this because this is a condition. So 11 over 2 should be shaded. So the sign of this fraction, it's negative between minus infinity 2 over 3 union 11 over 2 plus infinity. It's positive between 2 over 3, 11 over 2. Now solving the inequations or the inequalities of the second degree. So this is an inequality and you solve it the same as if it is a polynomial. Okay, so we just pretend that it's a polynomial. We find the delta, we find the roots, we put them on the table, and when you do the table, you only check the positive if the inequality is positive, or you check the negative if the inequality is negative. Okay, so suppose we have minus 2x squared plus 3x minus 1. We need a positive. We need to check where is this inequality positive. Okay, so the first thing we do is we solve it. Delta positive, or in this case we have a plus b plus c equals to 0. So the first root is 1 and the second root is half. Moreover, you have to pay attention that the a is negative. Okay, so pay attention to this. Now, if you do the table, I'm going to sketch the table. Here we have half first, okay, half and 1. Both of them are roots, okay, and a is what? A is negative, don't forget. Inside the root, opposite sign of a, so we're going to get plus, and outside the root, it's negative. And we need the equation, we needed to check where is it positive. So where is the inequality positive? It's between half and 1. Okay, between half and 1. Why it's closed around half and 1? Because here we have or equal, so mean half and 1 are included in my interval. Now we have another example. Minus 3x squared plus x minus 5. We need to check where is this trinomial negative. This trinomial, it doesn't have any root. So if it doesn't have any root, so it takes the sign of a. What's the sign of a? It's negative. So this is negative for every x. Okay? So now, we need it negative, and it's negative for every x. So what's the solution? It's r. What's the meaning of r? From minus infinity to plus infinity, all these values satisfy this inequality. So whatever you replace the x by, you're going to get a negative number. Another example, we have x squared minus 2x plus 5. This inequality, we have delta negative, and so it takes the sign of a. A is 1, so it's positive. So this is positive for every x. But they are asking us to give them the solution where this inequality is negative. So this is impossible. Why? Because this trinomial is positive for every x. So it's impossible to replace the x by a value and you get a negative expression. So this is never verified, so the solution is fine. The last example, here we have minus 3x squared plus 12x minus 12. This inequality, or this trinomial, when you do the delta, it's 0. So we have double root, so it takes the sign of a. Okay, so the sign of a is already negative, so this is negative for every x, and we need it negative, so all the numbers are accepted. But I excluded the 2. Why? Because we don't have or equal, and they are asking us to tell them this trinomial is only negative, not equal to 0. So it's negative for every value between minus infinity and plus infinity except for 2, because if you replace 2, you're going to get 0, and 0, it's either positive, neither negative. Okay? And now, what if we have system of two inequations? How do I solve this? As you see, I numbered them 1 and 2. So I'm going to do each one alone. Okay, so I'm going to start by number 1. We're going to solve the first one, 2x minus 3x plus 2. As you always know, you have to take the condition x is different than minus 2. And the roots are, minus 2 and 3 over 2. Whenever you do the table inside the root opposite sign of a, you're going to get a solution which is minus 2 to 3 over 2. Okay? So we got the solution for the first one, and we solve the solution for the second one. Also, the second one admits 2 roots, and we do its own table, and after doing the table, you're going to get the solution minus infinity 1 over 3 union 1 to plus infinity. So now I have a solution for every inequation, but this is a system. So I need to put the two solution, as you can see here. So the first one, minus 2 till 3 over 2. This is from minus 2 to 3 over 2. You can see it, right? This is the first solution from minus 2. It's dotted because we don't have or equal, till 3 over 2. And the second solution, I'm going to change the color so you can see the difference. The second solution is from minus infinity to 1 over 3 and from 1 to plus infinity. We look for the intersection part. The intersection part is here. Okay, this is the intersection part. So the solution is from minus 2 to 1 over 3 union 1 to 3 over 2. Okay? The last thing I'm going to talk about, it's the relation between the sign of the roots and the sum and product. If we have two roots, one is positive and one is negative, definitely the product is going to be negative. If we have two positive roots, then the delta is going to be positive, the product is going to be positive, and the sum will be positive. If we have two negative roots, the delta is positive, the product is positive, but the sum is negative.